What's up, geometry students? We're going to do the review for the final. Make sure we understand how to do every single question. First questions, we should have remembered what it means to be like corresponding, how we have angle 1 in all of these places. We remember vertical angles are equal to each other. We then see angles 1 and 2 on a line. If angle 1 is 35, angle 2 has to be 135. 45. Remembering that angles in a triangle add up to equal 180. If I have an isosceles triangle and one of the angles is 70 degrees, well, we could have the situation where the other two angles are the same, and that means that the angle has to equal 55. And we could have a situation where these 70-degree angles are the same. They are the angles that are opposite the equal sides, which means this third side is 40. This third angle is 40. Oh. It's very important for these questions to draw pictures. Whenever you don't have pictures, don't just assume that you can set up things correctly. We have a piece of string with a length of 100 split into two parts. One part is 24 more than twice the value of the other. You can either say this is like A, B, C, and you can say 24 plus 2 times AB. Or you could just use X, and that creates an equation that this plus this. And a lot of students forget that extra X has to equal this. 3X has to equal 100 minus 24, which is 76. And then we're going to divide by 3. And whatever that is, we'll leave it. I don't think we can do that. We got angle ROB is a right angle. Angle O. Triangle ROB. R is a right angle. This is interesting. So, yeah, it's not angle ROB. It's triangle ROB with angle O as a right angle. Angle O is equal to 10 more than 3 times the measure of B. So 90 degrees is equal to 10 more than 3 times the measure of angle B. Cool. So we get this equation for angle B is 80/3. And what is angle R? Oh, angle, I'm not just really screwing this up. Sorry. So as an example of like, don't rush, read carefully. Angle R is the right angle. Maybe I'll draw it this way. R is the right angle. OB. Angle O is 10 more than 3 times the measure of angle B. So I'm going to label B as X, and this is 10 plus 3X. Well, I know that these three angles add up to equal 180, or these two angles have to be complementary. They add up equal 90. 10 plus 3X plus X equals 90. Angle O is 70, angle B is 20. Segment BD bisects the angle ABC. So we got angle ABC. Segment BD bisects the angle. Angle ABC is 60 less than 5 times the measure of angle ABD. Okay, so I'm going to call ABD X. That means DBC is X. This is a good question. So doubling ABC equals 5 times ABD minus 60. And angle ABC is equal to doubling X. It's a very good question. So we get that X has to equal solving 20, 20, 40. 20 times 5 is 100. 100 minus 60 is 40. 20 plus 20 is 40. Wow, good question. It's a really good question. So angle DBC is 20. ABCD and F are congruent, so that means they're the same. B and E are right angles. They're not similar, they're the exact same. They could be similar, honestly. A corresponds to D. C will correspond with F. A is 18 degrees, which means D is 18 degrees. If this is 90 degrees, this has to be 62. 72. Oh, Pythagorean theorem. 4, 2. I mean, I immediately know that's just 2 root 3. But if you want to use the Pythagorean theorem, you'd say 2 squared plus b squared equals 4 squared. B squared equals 16 minus 4, which is 12. B equals root 12, which is root 4 root 3, which is 2 root 3. Ten 14 hypotenuse C. Colin Morikawa has got to stop double bogeying 18. Goodness gracious. Well, 10 squared plus 14 squared equals C squared. Simple calculator. 196 plus 100. 296. So I need to take the square root of 296. I don't know if that works out. Oh, it was times 100. Never mind. Plus 100. It was plus 100. I don't think this is true. You can divide that by 100. I mean, maybe. Maybe they want you to say this is root 100, root 2.96. I mean, let's just go with that. If this is the question, this is the answer. 10 root 2.96. N is 2.96. They're kind of forcing you to do this in this way. Cool. All right, so we just have to understand how to square 10 root 37 and 24 root 37. So 10 root 37 squared is 10 root 37 times 10 root 37, 24 root 37 squared, c squared. This will be 100 times 37. It's 10 times 10. It's root 37 times root 37. It's 10 root 37 times 10 root 37. You don't distribute everything to everything. You can multiply things in any order. 10 times 10. Boom. This is 24 times 24 times 37. This is some big numbers. Definitely need a calculator. 576. Worried about the root 37s. Can I just use 10 and 24 and not worry about the roots at 37? I guess I can because I could factor out this 37. And if this is something root 37, I can divide those away and just get that c squared equals, I think it was the intention of this, but like I never kind of done something. So I need to take the square root of 676. That's 26. I think that's what they wanted us to do. But if you just kind of plowed ahead, AC would then be 26 root 37. I guess it's like a scale factor. That's a good question. You can just like brunt your way through it. But you're going to get this big number. So watch me start this over. I like this question. I'm going to start it. I'm going to take another triangle. And this is a great way to think about right triangles is similar triangles. And I'm going to say, let's start with this right triangle. That's a little bit smaller. It's going to be a lot smaller. A prime, B prime, C prime. And it'll have lengths of 10 and 24. Cool, let's just do that. And we know that these lengths are going to be root 37 times bigger than these lengths. We can use the Pythagorean theorem with this. This is going to be the way to go. Where we do 10 squared. Oops. Clear. 10 squared plus 24 squared. Cool. Square root. And we get 20. Nope. 10 squared plus 24 squared equals square rooted 26. Cool. Well, then that needs to be 26 root 37. It's a very intuitive way to use the concept of similarity where you don't want to use the Pythagorean theorem with ugly numbers. This is very good question. I like this question. I'm bringing this to geometry next year. Give them like crazy numbers, but be like, yo, don't work with these numbers. Work with these numbers. All right. Equations of circles. We have a circle. What does it mean to be in a circle? Well, the definition of a circle, it's all points r distance, all xy points that are r distance away from a center. Well, what is the formula that we use to find a distance of a line segment? Well, we use the Pythagorean theorem. This can be memorized, but it also could be understood. Now, let's say I had the point 1, 2 and the point 4, 6. How do I know what r is? Well, you have to find this length here and this length here. How do we find the x length? Well, we do the difference of our x's. 4 minus 1 is 3. The difference of my y, 6 minus 2 is 4. Well, how do we do that here? We do x minus h. This is a very important thing, the minus h. How do you find that 4? 6 minus 2, well, y minus k. And then we use the Pythagorean theorem that it's x minus h squared plus y minus k squared equals r squared. And a lot of students forget about squaring r, and they think it's plus k and plus h, but it's not. This is just the Pythagorean theorem. Right, so I have a center at -2, 0. If I shift it down 6, my new center is going to be at 2, -6. -2, -6. The radius is twice that of radius 1. Well, if this r squared is 9, then r is 3. My new equation, r is going to be 6, and the center is going to be at -2, -6, which creates this equation, x plus 2, -2, you see the plus 2, squared, y plus 6 equals 6 squared. Cool. How do you find points on circles? Well, plug in 6. Doesn't work. If I plug in 6 for x, I'll get 6 minus 2 squared plus y minus 3 squared equals 25. This is 16. I got y minus 3 squared equals 9. We've been practicing this. After we square root, we get plus or minus 3, which means y could equal add 2 to plus and minus 3. So I get 5 and -1. So the answer is yes, it definitely could be possible because I get an equation that is solvable. If I'd have a negative number here, then it's not solvable, which I don't think I ended up figuring out. But we get 2 points, which kind of makes sense on a circle. You could have 2 y's that go with a specific x. If the y coordinate is 0, you'd have x minus 2 squared equals, this would end up being 9, so this would end up being 16. So yes, if you have y equals -1, you'd have x minus 2 squared. This will be -1 minus 3 is -4, 16. So this would be 9. So this is yes. If you get y equals -2, we would get x minus 2 squared equals 0, which is actually solvable. X is 2. So the answer for all of these is a big fat yes. Understanding why is because we can solve equations. I probably should have given you a different one where there was a no. So what about an x coordinate that is 9? Well, if you have an x coordinate that is 9, you'd have 7 squared, which is 49, plus y minus 3 squared equals 25. You'd have y minus 3 squared equals a negative number. You square root, you can't do it. You can't square root a negative. Great, the horizontal and vertical tangents to the equation. Well, we know we have a center at 2, 3. we know we have a radius 5. That's important to know. We see the horizontal tangents. We see the vertical tangents. How do we get those equations? Well, we know we need to go 5 out in the x and y directions. So when I add 5 to x, I come over here to 7, 3. If I subtract 5, I have negative 3, 3. If I add 5, I have 2, 8. Nice, Bryson just birdied. If I subtract 5, I have 2, negative 2. So these are the points. But what are the equations? Well, all of these points are going to have a y coordinate that equals 8. So this is y equals 8. All of these points will have a y coordinate that equals negative 2. So this is y equals negative 2. This will be x equals negative 3. All the x coordinates will be the same. All the x coordinates will be the same here. So we get y equals 8, y equals negative 2, x equals negative 3, and x equals 7. And we finish off with a tangent. What do we know about tangent lines? I know something. We got this point 2, 3. Then we got this point negative 2, 6. You can see the tangent line is just going to touch the circle grade. But a key characteristic of this tangent line is going to be its slope being perpendicular to that slope. Now, to find the equation of a line, we should simply use a point slope form. We should use y minus 6 equals some slope times x plus 2. All we have to do is work on the slope. We have to find the slope of this line, whether you use x and y and kind of figure it out here, or you get the slope of this line is negative 3/4. We can see it goes down, so that makes sense. The slope of this line would be perpendicular, which would make it 4/3. Cool, I have the points negative 6, 5 and 2, 5. These points are a diameter of a circle. Well, we can see, since they're the same y's, it's like a horizontal diameter. We should be able to find where the center is and the radius from there. How do you find the center? You can either use the midpoint formula, which I don't like to use, or you can intuitively say if I'm going all the way over 8, halfway must be 4, halfway must get you to negative 2, 5. And you can see that halfway would be the radius 4. All right, Maxima. So I'll have x plus 2, I'll have y minus 5, and I'll have the radius squared. Yeah, this is bad. I wonder if I could actually solve this question. Let me see. We got C is HK. We got A is H plus 1, K plus 3. And we got this point B. Oh, I mean, you can do this. Makes a right angle. Yeah, you could totally do this. This is the length of AB. Doesn't matter where B is, but this is the idea. All right. Well, easiest way is to maybe use points. Like plug in 2, plug in 3. You plug in 2 and plug in 3, you could see like, oh, if this is 2, 3, this would be 3, 6. That this length can be found. as +1 plus 3. This is root 10. If this is root 10, this has to be root 10. What is the length of AB? Well, it's a isosceles triangle multiplied by root 2, and you get, or use the Pythagorean theorem. AB is the square root of 20, or AB is root 10 times root 2. That's a good question. Which actually is the same as root 4 root 5, which is 2 root 5. That's great. Give you guys that as the answer. Equilateral triangle is inscribed in a circle, so it's on the inside. The center of the circle is the same as the center of the triangle. The radius of the circle is 4, so that goes to this vertex, that this is 4. What is the area of the equilateral triangle? Well, this is kind of like what we did back in the day with polygons, is like split them up into smaller triangles. And we realize that since it's an equilateral triangle, we have a bunch of 30, 60, 90 triangles, where if this is 4, that would correspond to a 30, 60, 90 triangle where it's small, medium, large, whatever, we'll keep it like that. Small, medium, large. So that means I'm going to like say this is times 2 to get to 4. So this is times 2 to get 2 root 3. Yeah. And this is times 2 to get to 2. Cool. So we can think of having 6 of these right triangles. We could think of this as one big triangle. We could find this entire triangle, but you got to know that this length is 4. I'm going to just find the area of this triangle and know I have 3 of them. So I have 1/2 of my base times my height. Well, half of my base is 2 root 3 times my height is 4 root 3. And then I'm going to triple that to get 12 root 3. You could also do half of your base, 2 root 3 times 6. Now it's important to know that this is going to be 6 because that length is 4. Well, and the next question is very similar. I think I got to draw the circle, then the triangle. I don't know how to do this. There you go. The perimeter is 60, which means each of these sides are 20, which means half of the side length is 10. The radius is W root 3. That's the radius of the circle. Well, just like this, I can see this is 10 over root 3, scaling. So this is going to be 10 over root 3, and this is going to be 20 over root 3. So really, it's a trick kind of question. We got 20 over root 3 equals W root 3. How do I solve? Well, if you divide by root 3 or multiply by 1 over root 3, you get root 3 times root 3, which is 3. Or you can multiply both sides by root 3 and get W times 3 equals 20. Area of the shaded sector. Well, the area of the entire circle is pi r squared. But I only have 72 degrees of the 360 degrees. I think that's a nice, easy number. It's a fifth. Cool. And the length of the minor arc, well, I have a circumference of 2 pi r but I only have a fifth of things, so I have 6 pi. Circumference is 60 pi. Diameter is PRQS. The length of PS is twice the length of arc PQ. Was the length of QR. I think it's just a setup here. 1, 2, 3, 4, 5, 6. 6 of my x's will equal 60 pi. So that means my x is equal to 10 pi. That's really heating up here. Max Homa. On fire. Where do you go, Max? All right, scaling is very, very important. Scaling is probably the most important thing you learn in geometry. A, B, C, similar to M and O, with the lengths of M and O double. Okay, so this is M and O, where B and C correspond to A and O. So if this is A, B, C, this is M, N, O. Angle C is 20 degrees. O has got to be 20 degrees. They're similar, which means it's not going to be, you're not going to double the lengths of the angles. You're going to double the lengths of the sides. Hope we understand that. A, B, C, M, N, O, or the vice versa. Angle C is 20 degrees. What's M? I mean, I don't. I should have told you where the right angles are. I mean, I'm going to say M is 90 or 70. All right, remember with scaling that your lengths times a number, your areas would be times the number squared, and the volumes would be times that same number cubed. If you know what this is, you might have to square root it to find like the length factor or cube root it. So we got X and Y. Surface area of X is 58. The surface area of Y is 1450. What is that times? The volume of Y is 1250. Okay, cool. What is that times? Let's figure out by dividing to figure out how many times the size. We got 25 times the size. So if this is 25 times the area, that means that's 5 squared, which means the lengths are going to be times 5 and the volumes are going to be times 5 cubed. So this is times 125, which means I'm going to divide by 125 to get just 10. Woo, Bryson. Save par. Okay, Bryson's minus 2. Circle A has a radius of 3n. Circle B has a radius of 21n, which means circle B is 7 times larger. I don't care where n is. How many times is the area? Well, the area is going to be times 7 squared. Lengths, areas, volumes. Okay, so XY is 6 times ZV. So if XY is 5, ZV has to be 5, 6. If it was like 1 to 6, then ZV would be 6 times the size, but it's written like that. Man, it's really heating up this tournament. Understand that the diagram is going to be smaller than the actual floor plan by a factor of 20. If the area square feet, the area is 1 in the diagram, then the actual area of the house is not going to be times 20, but times 20 squared. 20 times 20 is 400. So the area of the house is 400 square feet. If the volume is 2 cubic feet, then times 20 cubed so we go from a volume, maybe we got tall ceilings, of 2 to a volume of 16,000 cubic feet. I feel like I'm on best performance. I'm just checking. Nope. All right, trig. It's really just similarity, but with right triangles and making sure our ratios are consistent. We might have to use the Pythagorean theorem. That's like one extra thing with trigonometry is the fact that it's right triangles. So 42 squared minus 41 squared equals square rooted. Great, square root of 83. Just gonna leave it as that. So the sine of A, and we're using SOHCAHTOA, as this is like the definition of the ratios that will exist in these right triangles with these right angles. Sine of A is root 83 over 42. Any right triangle with the angle A, that exact angle, will have this ratio of their side lengths of opposite over hypotenuse. I hope I don't think you're close enough to the mic. I don't think we're picking you up. All of the triangles with angle A will have to have this ratio. So that means like you can also say, oh, if you have angle A, let's say it's smaller, we can have root 83 over 42 and 1. That is a possible triangle with A. Another possible triangle with A is 41 over 42 and 1. Another possible triangle with A is root 83 over 41 and 1, but with the 1 being the adjacent. Okay? Because you can always take this and divide it by 1, divide it by 1, divide it by 1. Cool. And that's what happens when you like use your calculator. You'll see that very few questions you'll actually be using your calculator. F, G, H, G, and K are the right angles. So F, G, H, J, K, L. The sine of F is 12 over 13. You can either say this is 12, this is 13, or you could say you have 12 over 13 over 1. Shit. I didn't mean this to be K. I meant this to be the sine of L. Well, it's not tricky, guys. You'll use the Pythagorean theorem to find side length FG. Okay, so we got 13 squared minus 12 squared square rooted is 5. Cool. And I don't care what the scale factor is, whether it's 2, 5, a half, a third. The ratios, the trig functions of this triangle are the same as the trig functions of this triangle. The sine of L has to be the sine of H, and the sine of H is 5/13. Hey, you wanna go on the internet forever?
You live?
Yeah, we're live. We're recording.
That's what golf is.
Oh, this is the PGA Championship, bud.
Alright. Good luck.
Thanks.
Yeah.
You watch golf?
There, right?
You watch golf?
A little bit.
It's a major. No advisory today. Later. A, B, C. C. J, K, L. L. B, C. J, K, L. J, K, 12. Guys are just draining putts. Since they are similar, they are proportional. If the cosine of A is 1 over 2 or a half over 1, well, I mean, you already know that it's going to be a 30, 60, 90 triangle. The only time you can have a cosine or a sine value of a half is if you have a 30, 60, 90 triangle. Well, now we know that JKL has got to be times 6 that. So if that's 12, this is 6√3, and this is 6. So KL is 6√3. So important. Use your right triangle. BC is 3√3, and AC, CD, sorry, is 3. Matthew Pavon sighting. GO, right angle E. GE is 4. Since it's isosceles, this is 4, this is 4√2. Remember you two isosceles right triangles, you got 1, 1√2, or you got the smaller triangle, 1 over √2, 1 over √2, 1. So OG is 4√2 and EO is 4. Yeah, another equilateral triangle. It's just a great question. It's just really a great question that like involves a lot of different things. 30, 60, 90s. This is 4, this is 4, this is 4, which means this is 2, which means this is 2 over root 3. We kind of did this question earlier, right? So this is a good practice. This is 2, this is 1, this is root 3. That means the scale factor is 2 over root 3 is why I do it. So this is 2 over root 3, and this is 4 over root 3. Cool. I have 3 of these triangles, so I do 3 times half of my base times the height, so 4 over root 3, so I have 12 over root 3 as my answer. You could also say this is 2 over root 3 and this is 4 over root 3, which means I have 6 over root 3, so I have half my base, which is 2, times 6 over root 3, which is 12. Bryson's on 18. Back. Let's stay. It's a birdie opportunity. Nope, it's rolling back more. Ooh, tough pin location. Cool. A's got to be 10. B's got to be 25. 2 pi r squared. This is a great question because like the volume of a prism is the area of the base times the height. So we kind of saw these questions on the SAT pop up. This is an area of the base. A lot of these SAT questions give you the base area. The volume is just 60 cubic centimeters. And now look, if you got centimeters squared and you multiply by centimeters, you'll get centimeters cubed. So they kind of give you everything you need to get this answer. Okay, cylinder base diameter is 8, which means the radius is 4. We want the area of the base, but that's going to be 16 pi times 3. 16 times 3 is a number. 48. Ooh, what about the surface area? Surface area, I got 2 circles. So I got 2 16 pies. And then I have this rectangle, which is going to be 8 pi after I roll out the cylinder. I have the circumference becomes that length and the height stays at 3. So that's 24 pi. So 32. Which is 56 pi. Cool. Yeah, so this is 16 pi. This is 16 pi. This is 24 pi. Six, 6, 5. Top is removed. So we only have 4 of the outsides and the bottom for surface area. So the volume is the area of the base times the height, which is 36 times 5. Cubic inches. I don't want to do math. 80 cubic inches. The surface area is the bottom, which is a 36, and then 4 6 by 5s, which are 30. So I have 120 plus 136. So the surface area is 156 squared inches. I have 5s, which is close. So they're giving us the area of the base. So if it's area of the base is 13, you don't have to worry about any pies. They're giving you the area of the base. So we just have 13 times h is 377. You just got to divide. So funny how like sometimes you gotta like read the question carefully. Don't assume it's gonna be tough. It's 29. But now we got to know that the area of base is pi r squared. Cool. So now the volume is still 377, but the height is 13. So we get that that is true. And we got 29 divided by pi square rooted is the r. I'm gonna write that nicely. Oh yeah, hexagons. You guys remember hexagons? They're the best hexagons. That's a gross hexagon. Let's try again. All right. Why do we love hexagons? Why are they the best hexagons? Because they create equilateral triangles. So this is another real like drive home of the 30, 60, 90 triangle. This is 2, this is 4, this is 4, this is 2 root 3. Use your 30, 60, 90 to help you. So the volume is the area of the base times the height. The area of the base is this 4 root 3 area of this triangle. That's half of the base times the height times 6. 1, 2, 3, 4, 5, 6. So that's 24 root 3 times the height of 6. So 24 times 6 root 3. The volume is 144 root 3. The surface area is 2 of these guys and then 6 of the 6 by 4. So 2 of these guys are 2 of the 24 root 3s. So that's 3 times 6. 24 root 3 times 2 is 48 root 3s. So I have 48 root 3s. But then I have the 6 rectangles who have an area of 24. So I have 6 times 24. And that is 144. It's just like a good tournament. I mean, honestly, it's still a good tournament. People moving. Homiciding. Cool. Good question. What about this guy? This is fun because this is 5 and this is 5 root 2. Okay. If I have a 1 root 3, 2, what is the scale factor? 5 root 2 over root 3, right? Like you divide the two numbers, which means this is 5 root 2 over root 3, and this is 10 root 2 over root 3. Like, isn't that gross? But it's like doable. The area would be 25 halves, which is this, plus half the base, which I'm going to say this is the base times the height. Okay, so I have 25 halves plus the 5 times the 5 is 25. The root 2 times the root 2 is 2, but I have a half here, and I'm dividing by root 3, which means the half and the 2 will cancel, which means I have an area of 25 over 2 plus 25 over root 3. What a great question. It's going to be annoying to go back and erase all this because I'm just going to provide the answer key to start with before I provide the video. But we're moving right along. Oh, we're almost done. Let's plow through. Let's plow through. Okay. These two lines both intersect each other and the x-axis. What is the area of the triangle? Great question. Well, we got to find where they intersect the x-axis. That's when y is 0. So I'm going to plug in 0, and I'm going to get that this line is going to be at 8, 0. Great. I'm going to plug in 0 here. And I'm going to get this line is going to intersect at 2, which means this base length is 6. And now I have to figure out where the two lines intersect each other. And oh boy, if you're in my class, we've been doing this a lot. I'm going to add 1x to half of x and get 3 halves of an x. I'm going to add 1 to get 9. I'm going to divide by 3 and multiply by 2. And dividing by 3 is 3 times 2 is 6. So this is 6. And if I plug in 6, I get 2. This height is 2. Half of the base times the height is 6. What is this? Plug in 0, get 4. What is this? You can solve, or you can just know, like, if I plug in 8, I'm going to get 0. The area of the triangle is 1/2 8 times 4, because this is 8 and this is 4. So a half of 8 is 4. 4 times 4 is 16. If the triangle is spun around the x-axis. What a great question, guys. What do we notice? Well, if we spin this around the x-axis, twist your fingers for the x-axis to spin, we realize we got this circle that shows up here. And we have a cone. What is the volume of a cone? 1/3 pi r squared h. What is r? R is going to be 4. What is h? H is going to be 8. So I have 1/3 pi times 16 times 8. Let's get that number. I don't think I can divide that by 3. I think it's 1/28 pi. X equals 0. You got to know it's the vertical line. X equals 3. You got to know it's a vertical line. Y equals 1, horizontal. Y equals 5, horizontal. Find the intersections if you want to, you know? This is 0, 5. This is 0, 1. This length is 4. This length is 3. What is the area? 12. Spin this around the y-axis. Circles on the top and on the bottom. Height right there. Spin that around the y-axis. This radius is 3 because it's going to go all the way. This 3 is going to go all the way around the circle. This height is 4. We have a pi r squared h, which is 9 pi times 4, which is 36 pi. Spin around the x-axis, and all of a sudden things get a lot harder. This is spun around the y-axis. Boom. Spin around the x-axis, things get harder because we have this toilet paper roll. Get my drift. I'm a little being a little. I didn't do a good job with the 3-dimensionality of it. Anyways, we realize we have like an outer cylinder and an inner cylinder. So I want like pi, my bigger radius is squared times h, and then I want pi, my smaller radius is squared times h. But I realize that I have to use this entire radius 5, and then I have to use this entire radius of 1. So I have a height now of 3. So I have 75 pi minus 3 pi, which is 72 pi. Sweet. Okay. Randomly selected student selects a tiger. Tigers, 24 out of 80. sixth grader who picks a lion. Any randomly selected student is a sixth grader who picked a lion. Only 9 out of the 80. That a seventh grader picked a tiger. 9 out of 26. Student picked a badger. This is the sixth grade. Is an eighth grader, or they picked a longhorn. 31, 41 out of 80. Gosh, I love these questions. Those are just so fun. We talked about solutions to the systems being the shared intersection. We learned how to set up, solve by hand intersections of functions, and we are done. If you subtract x squared, if you subtract 3x, if you add 1, you get this. Don't forget about the equals 0. I want you to write that x squared plus x's plus numbers can come from the factored form. I made the key. I'm going to erase all this and just post the key to start. I'll post the video like, I don't know, in like maybe next week, you know? I don't want them to like, I want them to come into the math office. Cool. Did you already make the key? Cool. I'm done. I have like just the answers. I'm just going to post the answers. All right. Peace. Oh, hold on. We probably get the y values. Whatever. Plug in the x's to get the y values. I don't have that kind of time. 18, 17, that's no big deal. 16 plus negative 12 is 4. 3. Boom. All right. Mr. Messer's out to 24, 25. Last video. Peace.